Welcome to AP Calculus, AB, Lesson 10-3, Average Value of a Function. This, incidentally, is the last lesson of the school year. And we're going to begin by reviewing something that we've seen before, the mean value theorem. Here's how the mean value theorem is stated. If two things are true, the first being that our function is continuous on an interval starting at A, ending at B, and including both endpoints. And the same function is differentiable on the same interval, not including the endpoints, then we can come to this conclusion. There exists some x value, we'll call it x equals z, on the interval from A to B, such that the derivative at this point is equal to the slope of the line that connects the two endpoints of the curve. And we should make note of the fact that in this case, the slope of the line connecting the two endpoints is what we call a secant, slope of the secant, and the derivative at that point we'll call the slope of a tangent. So there's the mean value theorem. You're going to see that come up on the AP exam. Let's look at how we use that in a situation. Look at example number 1. Okay. So our function here is g of x equals 2/3 x to the 3/2 power. And we want to find that x value on the interval from 0 to 9. You have to have an interval. If you don't, there's no way to do the problem. That makes the mean value theorem true. So the first thing that I'm going to do is simply draw a sketch of this graph. Now I put this in my calculator and found that at 0 it's 0, and at 9, the other endpoint, the value of our function is 18. And the curve is going to look something like that. Not as curvy as a parabola, but curvier than a line. So let's look at the slope of the secant. The slope of the secant in this case would be the change in the y values, which is we go from 18 to 0, over the change in the x values from 9 to 0, which is equal to 2. And you can pretty easily count that off simply by looking at this secant right here. Please note that the scale of the y-axis goes by 2s. Alright, so we want to find the tangent that has that same slope. Looks like it's going to be somewhere around here. I'm thinking about 4. So the slope of this function is given by the derivative, which is, using the power rule, 3/2 times 2/3 x to the, knock the power down by 1, 1/2, which, note that the coefficients cancel. We're just left with the square root of x. So, since we want the slope of the tangent to be the same as the slope of the secant, and we know that the slope of the secant is 2, and we know that the slope of the tangent is going to be, bring this around, just the value to the 1/2 power. I'm going to call it c to the 1/2 because we're looking for a specific point now. C to the 1/2 equals 2. C must be equal to 4. There's our 4. Slope of the tangent.